Dear students, greetings. Welcome for this lecture. In this lecture, we are going to discuss about IPv6 address, how we can represent the IPv6 address, how we can identify the different types of address in the IPv6. Okay. So this is the lecture 26, week 9, lecture 2, classroom discussion topic 26, IPv6 addressing. Okay. So in this video lecture, we are going to discuss about lecture outcome. After completion of this lecture, students will be able to abbreviate and elaborate the IPv6 address. And students are also able to represent the type of IPv6 addresses. And student will be able to identify the given address is reserved address or not. Okay. So this is the outcome of our lecture. What is IPv6 address? Internet Protocol version 6 address. Okay. The main reason for migration of IPv4 to IPv6 is small size of address space. So already we know that IPv4 have 2 power 32 addresses. So all over the world the population is more. So that is not enough to provide the addresses for all the people. So for that reason, we are shifted the IPv4 to IPv6. The main advantage of IPv6 is it's have 128-bit address. Okay. So IPv4 is 32-bit address. So we will get 2 power 32 addresses. If IPv6 we are providing with 128-bit address means we will get 2 power 128 addresses we will get. Okay. So if you want to say in the bytes means 4 byte it will take IPv4, but here IPv6 is taking 16 bytes to represent the IPv6 address. How we are represent that IPv6 address? In IPv4, there is a dotted decimal notation, dotted decimal notations and binary notation we are used for IPv6. So these two for IPv4. But in IPv6, when we are compared with this, 128 bits are there. So if we are saying that binary format, we are unable to write that many number of bits. Okay. So here IPv6, we have two types of representation is there. One is binary representation, that is combinations of zeros and ones. Then colon hexadecimal notation, or hexadecimal colon notation, or colon hexadecimal notation. How we can write it using the hexadecimal notation? The colon hexadecimal notation divides the address into 8 sections. Okay. So previously IPv4, we have 4 sections separated by the dot. But here we are separated by colon. That is colon decimal notation, colon hexadecimal notation. You just consider here 128 bits are there, that is combinations of zeros and ones. So these 128 bits will be converted into 16 bytes. So in IPv4 we have 4 blocks. Each block have 8 bits, like totally 4 into 8, 32 bits there in the IPv4. In IPv6, so again we are considered the 16 bytes. When we are converted into bytes means 128 by 8. So 16. Okay. So 16 bytes is there. So each byte how we can represent? Again, 16 bytes are there. We want to represent 128 bits. So how we can represent in case if 16 bytes will be represented into 8 blocks. Okay. So here this yellow color is there. No, yellow color representation is 8 blocks are there. So each block have 2 bytes. Each block have 2 bytes. Total 8 blocks are there. So each block will represent 2 bytes. That means 16 bits. So these 16 bits will be represented with the hexadecimal number. Okay, each hexadecimal number. What is the hexadecimal number? Hexadecimal number is base 16. Okay, so 0 to 15 it will be there. So 0 to 9 as usual, 9 values. After 10, A, B, C, D, E, F. Up to 15, F will be there. This is hexadecimal number. So these used this hexadecimal number. Hexadecimal number means 15. How we can represent in the binary? 4 bits we need to represent the hexadecimal number. So here 16 bits are there for each block. So 16 bits is there. Each hexadecimal number it will take 4 bits. So totally 4 number we used for represent the each block. Clear? So each number have 4-bit representation. So 4 hexadecimal number will represent each block. So 4-bit will represent the hexadecimal number and 4 hexadecimal number represent the each block. So totally 16 bits. Then total 8 blocks. You can consider this 4 bit will represent the hexadecimal number. 4 into 4, 16 bit will represent the 1 block. So 8 block we are used here. So here what each block how many representation is there? 4 plus 4 plus 4 plus 4, 16 bits. Okay. Sorry. So 4 into 4, 16, 16 into 8, 128. Okay, so total 128 bit we are representing. So some rule is there for how to write the simplify the entire address. These many numbers are there, no? So we are remembering is very difficult. For that, how we can short the entire address. So abbreviation of IPv6 addresses. So first one, even in the hexadecimal format, it is very long. Okay. So many of the digits are 0. So 128 bits, maximum bits may be zeros. In this case, we can abbreviate the address. How we can abbreviate? First rule. We have to omit the leading zeros. Each block, if any zeros are leading, that bits will be omitted. For example, 0074 is there. We can omit these 2 zeros. We can write it into 74 only. Okay. So instead of 4-bit representation, sorry, 4 hexadecimal representation, we are using only 2 hexadecimal number. So here also 000F is there. 3 zeros are leading zeros, so we are omitting it. We can write it F only. So in case 40 is there means we can write it only 10. Okay. But in case 0 is in the after the number, if it is there means no need to abbreviate means there is a meaning is there. We are not able to omit it. Okay. This is the first rule. Second rule, compression of zeros. Okay. Second rule is compression of zeros. That is zeros compression. What is a zero compression? Applied colon hexadecimal notation if there is a consecutive sections consisting of zeros only. Okay. So how we can write it? Applied hex notation, colon hex notations. We can remove all the zeros and replace them with double semicolon. not semicolon, this is colon only. Okay. So we can represent, if continuous zeros are there means we can remove all the zero. So just we will keep double colon. Okay. So this is the next condition. So note that this is the type of abbreviation is allowed only once per the address. This double colon is there, no? You have to use only one time. Okay. So for example, here 00000 some bits are there. So in between some numbers are there. Okay. 4444. So then 00000 is there. Okay. So don't use like this. Here double colon 4444 double colon. So this is wrong. Okay. So you have to use only one time. This representation, you just see this, they are given the original address. So you have to abbreviate it. So here, first condition, leading zeros, we have to omit it. So if we are leading zero, here it is there, we have to omit it. Here also 40 is there means we will keep two single zeros. Okay. So here there is no zero, we can use same. Here 40 is there, we will keep zero. Here no zeros leading. So what happened? Here remove two zeros here. Here remove instead of 4010 like this. So here also we return. So in this abbreviated form, these consecutive zeros are there. Consecutive zero blocks are there. So once it is there, we can just remove all the zero. We will keep only double colon. Okay. While you are expanding, what you have to do? You have to start from this left side up to double colon. Okay. So here these four numbers it will come again same thing. FDEC colon 74 is there. That means we can add 0074. Then double colon is there. No, you will keep it here. Then you have to start from the right side. Because how many zeros you want to include, you don't know. Okay. So total 8 blocks. Here one block over, here second block over. Then we will start from the right side. Right side, again FF triple F 0, then colon 0 is there, instead of that 40 we will write. Then BOF F is there, colon. So in between, how many zeros are there? We don't know. So here now, 2 blocks over, third block over, fourth block over, fifth block over. So total 8 blocks. So 8 minus 5, 3. So 3 blocks we can include the zeros. Okay, like that you can expand the IPv6 address. So mixed notations, how we can mixed notation means there is a colon hexadecimal notation mixed with dotted decimal notation. How is possible? So somewhere we want to mention the IPv4 address using the IPv6 address. For that, rightmost 32 bit, it will be allocated for IPv4 addresses. These 128 blocks are there, no? So out of that, so first this 96 bits will be IPv6 address. The remaining 32 bits may be for representing the IPv4 address. Okay. So see here, this is the another representation, double colon, remaining are IPv4 addresses. Okay. So these double colon represent that all zeros. So 96 bits are zeros, the remaining 32 bits are IPv4 address. So now you can answer for this question. Write it in your notebook. 10 seconds time. So you have to expand the answer. Okay, good. So now time over. Just we will see the solution. Okay. What we have to do? So first time expansion. Single zero is there means 40 you have to write. Colon. 15 is there means leading zeros are there. So you can write it 15. Okay, then double colon is there, you will keep, you will stop. Then again we have to start with this side. 1, 2 and 3 is there. Then 12 is there. So leading zeros will be there. Then 1 is there. Leading zeros are there. Okay, so here also 1, 2, 3, 4, 5 blocks are over. So remaining 3 blocks are there. So 3 blocks you will keep zeros. Okay, so this is the answer. So this is the final answer. If you are written properly, you can continue this video. Otherwise, you will go back and watch the video. Then you will try it. Okay. Now slash notation. In IPv4, we are used that slash notation for classless address. Here we are used for prefix and suffix notations. Same purpose we are using. So example slash 60 means first slash the 60 bits will be represent the prefix. Okay. So for example, you see here compared with IPv4, how many addresses are more? So there is a 2 power 32 addresses. Here 2 power 128 addresses. So total difference is 128 minus 32. So total 2 power 92 addresses are more compared with IPv4. These many addresses are there. Okay. So if we have these many addresses, what is the meaning of that? The entire world, like in Earth, the people have maximum 16 billion. If that means 2 power 34. If 2 power 34 means remaining 2 power 88 addresses is there. So these each people will use 2 power 88 address. So there is no depletion will come. Okay. In IPv4 we have different classifications are there like class A, class B, class C that according to the binary values. Same like that in IPv6 classifications are there. The entire 128 bit will be represented like this. Okay. So here slash notation they are used for some special addresses. You just remind these slash notations how it will be used. The block prefix are like this. If 8 zeros are there, then it is a special address. Okay. So if 001 is there, so like /3 is there means that is a global unicast address. Okay. So same like that you have to remember it. So this is the entire representation. So first 3 blocks represent the provider prefix. First 3 bit especially that is the type identifier. It is defined the provider based address. Okay. So that is the type identifier. The next one is 5 bit. That 5 bit represent the network information center details. In case 11000 means internet network information center. So in case 01000 means center of European registration. So in case 10100 means Asia Pacific network information center. Okay. So this remaining part is this one is the provider identifier. Who is the provider? So service internet service provider is there, no? That is the internet service provider. This is a subscriber identifier. Okay. So then this is a subnet identifier. Last one is the node identifier. So you know if you have using any mobile phone, you have some service provider. So that address will be there. So in case you are using some private network like Airtel or Idea or Vodafone, that identifier address will be there. This is a subscriber identifier. You are the subscriber. So you this address will be represent the identifier. So in case if you are using some landline, you are using some other devices for sub network. For that, it will be represent the node identifier. Okay. Here, unicast address is there. So we know already unicasting, multicasting, and broadcasting. In IPv6, there is no broadcasting, only multicasting or anycasting. What is anycasting? Anycasting means is delivered only one member of the group. So we know that multicasting means one message will deliver to the group. All the members of the groups are received the same copy. That is multicasting. Okay. So example, our WhatsApp group messages. If I am posting one message, all the students are receiving the copy of the message. That is multicasting. But anycasting means if any one of the person will receive the message from the group. Okay, that is the anycasting. So example, if you are posting query in the Google, if you are searching word means, so many servers have many data, but which is received the first, reached the first server, they will respond immediately. That is anycasting. Okay. So example, I am posting the message. Where is your class in your group? Who is seeing the first, they will reply. Okay. So that is anycasting. So multicasting, we know the group members will receive the copy of it. Broadcasting is not possible. That is one of the special case of multicasting only. So here multicast address, how they will represent? So they will represent using 8 bits will be ones. So if ones are there means that is considered as the multicast address. Second one is flag. This flag will represent it is the permanent group or transient group. Permanent group address means is defined by the internet authorities. Okay. It's now accessed by all the times. But transient group means that is other hand it is only used for temporarily. For example, I will using the video conferencing through Zoom for your class members. So for that purpose, they will give some IP addresses, group IP addresses. That is considered as a temporary IP address. So in IPv6 address, there is a different type of reserved addresses is there. How it will be identified? First 8 bit should be 0. The remaining 120 bits are zeros means that is unspecified address. Total 128 bits. So out of 128 bits, 8 bits are zeros. The remaining all also 0. That means all the bits are 0. Only zeros means that is unspecified address. Okay. So here in case first 8 bit will be the represent that unicasting or multicasting. So here all zeros. The remaining 120 bits, out of 120 bits, 119 bits will be zeros and one last bit may be 1. Okay, so if it is there, that will be considered as a loop back address. Okay, so in case 8 bit is there, then we have to use last 32 bit for IPv4 addresses. Remaining all bits also 0 means that is a compatible address. So we are representing now double colon with IPv4 address dotted decimal notations. We are used to know that previously I explained. Same method, that is compatible address. Okay. So last one is 8 bits are 0, then 72 bits continuous zeros, then 16 bits ones, then last 32 bit represent the IPv4 address. This means mapped addresses. So these are the reserved addresses in the IPv6. In IPv6, local address also is there. What is local addresses? These addresses are used when the organization wants to use IPv6 without being connected to the global internet. Okay, so without connecting internet, the local environment, they can provide the IPv6 address. How they can provide? Addressing with the private networks. So nobody outside the organization can send the message to the node in the addresses. Only two type of address is there, link local and site local. So the first 10 bit which will take represent for these local addresses. In that first 6 bits will be the one, the last 4 bits are 1010. If it is there, that is the represent the link local address. The remaining 70 bits are 0. Last 48 bit will represent the node address. That is 48 bit where we are using normally in link layer addresses. Okay. So last one is site local address. Here also you just see there first 10 bits are 1011. 6 ones continuously, then 1011 should be there. That is for site local addresses. There 38 bits zeros will be there, and then 32 bits are subnet addresses will be there. Then last 48 bit will be represent the node address. Okay. Node address maximum. What is it? MAC address. So now we are discussed about the IPv6 addresses. We know that 128-bit length is IPv6 address. It is used with the hexadecimal colon notation or binary notations. So different types of addressing we've seen, like multicasting, anycasting, unicasting. There is no broadcasting. It's a type of multicasting. And link local addresses. Then those address types we discussed, and slash notation we are discussed how it will be used in the IPv6, and reserved addresses we've seen now. So like compatible addresses, looped addresses, those we are discussed. Then local addresses we discussed in the last slide. This is a summary of this entire lecture. So now we have to revisit the lecture outcome. Having completed this discussion on IPv6 address in this lecture, now students should be able to, the student will be able to abbreviate and elaborate the IPv6 address. They are able to represent the type of IPv6 addresses and also able to identify the given address is the reserved address or not. Okay, so these are the lecture level problems. These problems based on the lecture outcomes. LLP1 is based on lecture outcome 1. LLP2 will be used for represent the LO2, and LLP3 represent the LO3. So please try it in your notebook. We will discuss this topic in the classroom discussion. For further readings, you can refer the textbook Data Communication and Networking 5th edition, authored by Farozan, in chapter 22.1 IPv6 addressing. Okay, if further doubt is there, you comment with me. Then also you can check with the tutorial sheets. Thank you. I hope you are enjoyed the video. If any doubt is there, please comment and discuss in the classroom. Thank you very much.